You have a 130 kilogram crate. So you can able to see a 130 kilogram crate. So it is at a stationary position. A person is pulling that crate, right, to an angle theta. So the angle here is mentioned as this 8 degree, and the diameter of the rope what he is pulling is 15 mm. If that is the case, you have to identify what is the normal stress. For this, let us consider, so I'll put a small plus sign here. So this sign indicates what will be the force, how the force will be acting. So if I consider a force here, so one force will be like this, another will be like this, and the third one will be like this. Okay, so you have three forces. So you have to identify what are that forces, and you have to find out what is its value. So again, for this problem also, I am going to use Newton and mm to solve this problem, right? So this I'll draw a free body diagram. So as like your engineer mechanics, we are going to follow the same. So I'm going to put a plus sign here. So you have forces. So let me consider you have a force here. You have another force acting like this. And third force vertically downward, right? So these are the three forces you are having. So now I'm going to identify what are the forces applicable for a particular thing, that is tension. So you can able to see here. So this one will be TBA. We call this as TBA. Tension along the rope B to A. And this one is TBD. Tension along the rope B to D. And this is weight. So weight is 130. So can you tell me 130 into 9.81? So what is the value?
1275.
1275.3 Newton. Very good. Thank you. So this is my forces. And you can consider here. So if I consider angle, this angle is 8 degree. And this theta is given. Theta is given as 20 degree. So we have to identify what is its values. So you have three forces. So what we will use here? Can anyone guess? Three forces. So we go for Lami's theorem. So according to Lami's theorem, we know the formula. What is that formula? So the formula is this: force by opposite side, so which is TBA divided by opposite side. What is my opposite for this? This angle, right? This angle. So this is force opposite to between the other two forces. So totally it is 90. 90, 20 has gone. Remaining will be 70. So this will be sine 70 is equal to TBD by sine opposite. What is my opposite angles? My opposite angles is here. So this one and this one, right? So this one is 82, right? 82 degree plus 90 degree. So what is the total?
172.
So total is 172 degree, right? So the next one is, so this 1275.3 divided by sine of its opposite angle. So my opposite angle is 20 plus 90 plus 8. So 28 plus 90. So 28 plus 90 will be how much?
118.
118. 118 degree. So this is what we are going to use. But my aim is not to identify all the forces. It is not engineering mechanics. So my aim is to identify what is the stress developed in rope AP. So my aim is to find out my stress developed in rope AB alone. So which means I have to concentrate to identify value for AB alone. So don't consider this BD and all. That is not required, right? So just for calculation, we have just drawn it. So for understanding, but our aim is to find out only AB. So which means my equation will be TBA divided by sine 70 is equal to 1275.3 divided by sine 118 degree. So yeah, I'm not going to use the other part. Let us identify what is my tension, right? So what is my TBA? So TBA will be 1275.3 divided by 118 degree into sine 70. So what is my TBA?
57.
1357.2 Newton, right? Very good. Thank you. Thank you. So now we identified what is my force. Force is identified. For the formula I need stress, you know what is the diameter of my rope. So we know what is the diameter. So diameter is given. So diameter is, so it is 15 mm, right? So which means my area. So my area is pi by 4 into 15 square. So we have to identify what is the cross section area. 176.625 mm square, right? So we identify what is my force and what is my cross section area. So the next step is my stress. Stress is force by area. So P, what you indicate here is TBA, right? Don't get confused. So which is equal to 1357.2 divided by 176.62.
Yes, sir.
So 7.68 Newton per hour
Newton
square.
meter. Newton meter.
So let me consider you have a handbrake shown in the figure. So the thing is, so you are applying a force, actually a uniform load, which is converted as a single point load. Okay, but it is around 70 Newton, right? So when you apply a force, something like that for 70 Newton, what happens is, so there will be a tension which is produced on your brake wire. Okay, so the question is, what will be the stress and what will be the strain on the particular brake wire? So this is what they're asking, right? So they also mention few datas. So what are the datas? They mention what is the length of your brake wire or brake cable. So they mention what is the cross section area. They also mention what will be the elongation. So after you apply a brake. First, we will consider what are the given datas. So if we consider our given data, so you have force P, which is 70 Newton. And if you look after that, they also given what is the length of your brake cable. So length L, which is mentioned, which is around 460 mm. Then cross section area. So area is also given. So cross section area A is equal to 1.075 mm square. And the elongation. So after you apply brake, there will be a small elongation. That is also mentioned, del L. So del L is mentioned as 0.214 mm. So what they are asking to identify, they are asking two data. So what is your stress and what is your strain? So these are the two data they are asking, right? So the first step is let us identify strain. So because we know all the data related to strain. So first let us identify what is the strain. So strain is, you know that strain is change in length by original length. So you know what is my change in length? Change in length is directly given, which is 0.214 divided by original length. Original length is what is the length of the cable? Length of the cable is 460 mm. So it is 460. So what will be your strain? if you just substitute these values. So 0.214 divided by 460.
4.65 into 10 raised power minus 4.
4.65 into 10 power minus 4. Very good. So we got this as a strain, right? So the next step is I have to identify what is the stress. To identify stress, my formula is force by cross-sectional area. I know cross-sectional area, which is 1.075, but only thing is I have to identify what is my force. So that deals with this picture. So this is, consider this as an engineering mechanics problem, right? So we have some problem like this. So we have to identify what is the tension T, which is acting here. Okay. So when you apply a force, what happens? So you can able to see that this point A, will have rotation, which is moment. You have moment at this point. Okay. So what I'm going to do is, in order to avoid moment, if you don't have moment, you will have a reaction force. So let me say moment at A is equal to 0. So I'm going to say moment at A is equal to 0. So when I consider that, you know what is the formula for moment. Moment is force into perpendicular distance. Okay. So what are the forces you have? You have two forces. One which is P, which is here. So you can able to see here. This is my force P, and you know what is the length, perpendicular distance with respect to that. So this is 100, this is 50. So the remaining will be 50 in that at the center. So this is 25. Okay. So the perpendicular distance from point A to your force is 50 plus 25, 75. Right. So it is rotating in clockwise. It is rotating in clockwise or anti-clockwise. Sorry, anti-clockwise. It is rotating in anti-clockwise. Right. So P force into perpendicular distance. Perpendicular distance is 50 plus 25, which is 75. Right? So force into perpendicular distance. Right? Similarly, let me consider this one. This is rotating in clockwise. Right? This is my T force. So tension. So this tension, you have a perpendicular distance of 37.5, which is minus T into 37.5. Why have negative? Because it is rotating in clockwise. Okay. So this is equal to 0. So my aim is to identify T. So T is equal to P into 75 divided by 37.5. So what is the value of P? So P is already given. So T is equal to P. So overall force P is 70. So T is equal to 70 into 75 divided by 37.5. What is the value of T? Yeah, your T is 140 Newton. Right? So now your T is nothing but your force in this case, right? So I identified my, so let me take this thing again. So this is my value, which I am going to put here. Okay. So my stress is equal to force, which is 140 divided by cross section area. What is my cross section area? 1.075. 1.075. So this is stress. 140 divided by 1.075. So you are getting around 130.23 Newton per ounce. Why we are identifying the stress? What is the purpose? What is the necessity of identifying the stress in the cable? Right? So this cable, so it may be a particular material, right? So let me consider it is having a mild steel, right? Or some material. So let me call this as a mild steel. So your cable is a mild steel. So the mild steel, you have what is the yield strength, right? Which is the maximum strength, still elongation. So still avoiding the elasticity. So up to elasticity limit is yield strength. So your yield strength, let me consider, it will be around 1 into 10 power 5. 1 into 10 power 5 Newton per meter square. Right? This is my yield strength. Okay. So usually it is around 1 or 2. So it relates on particular value. So other than this, so this is the maximum value. So which means your stress should not exceed this 1 into 10 power 5. Okay. So, but what we have, it is very, very less. It is 130, right? Only if it cross this 1 into 10 power 5, your brake cable will fail. Okay. So in this particular case, it won't fail. It will withstand. It will withstand. But there are some other cases like fatigue failure, right? Fatigue failure. If I consider fatigue failure, this I have to divide it by 8 or 10. I have to reduce it a lot. Okay. So what is fatigue? Fatigue is you are applying and releasing the load again and again. It's a continuous process. So brake, what we'll do, at least in a month will be applied around 1000 or 2000 times. Okay. So in that case, so if I consider for a whole term, right? So if I consider for 10, let me consider 10 years or something like that, you have a particular cycle, right? For that much amount of time, you are applying the brake and you are releasing it, which means you are applying a force, releasing the force, applying the force and releasing the force. So this we call it as a fatigue. Okay, loading and unloading. So this may cause a failure in your strength. What happens in a particular time, duration of time? For example, after 2 years or 3 years, your yield strength will reduce. Instead of 1 into 10 power 5, your yield strength will be around 0.1 into 10 power 5. Right? It is reducing year by year. Right? So when it reduces year by year, again your stress is same. It should withstand accordingly. Right? So that plays the major role. Okay, so that is the purpose of identifying this. So it should not cross your yield strength. Right? It should have a value which is at least 100 times greater. Right? Your yield strength should be 100 times, at least 100 times greater than uh, your stress which is developed. So then only what you can withstand all types of uh, other criteria, because everything we are assuming it, right? So we are not consider what is the environmental condition. So in cold season it will be different, hot season it will be different, right? We are not consider what is the how much force you are applying it. It is an impact force or a gradual load. So when you apply a brake, you can apply it suddenly, or you can apply gradually. So this also has a major cost. Then what is the amount of time you are applying it? So all these things comes into picture. So always it is related to that. Okay, so that is the purpose of this stress. Okay. This is also another problem. You can able to see here. You have a car, right? So a winch car, something like that, which is around 130 kilonewton. So when it is fully loaded and slowly it is connected to a cable and it is moving towards upward direction, right? So the angle is given, which is 30 degree, and the cross section of the cable is also given. It is around 490 square. The question is, they are asking you what will be the tensile stress in the cable. Okay, it is also a, what you can say, it's a combination of your EMEC problem and your strength of materials problem, right? Something related to that. Okay, first, what do I do? I have to draw a free body diagram, right? It is similar to your engineering mechanics, as I told you. So this is my winch. My winch is like this. Okay, this winch is having a cable tensile force T at 30 degree, weight W, which is acting downwards, right? Weight is around 130 kilonewton. And you have two wheels, right? So one wheel and two wheels. So you know that your reaction of this wheel will be always perpendicular to your connection. So which means here you have one reaction, here also you have one reaction. We consider R1 is R2. And this two is also at an angle of 30 degree, right? This is my free body diagram. Okay, so to solve this easily, what I can do, I have to change my X and Y axes, right? So what I can do, I can consider this as my X axis and perpendicular to that as my Y axis. Okay, so what happens when you do it like that? So you can easily locate. So you have only 130 kilonewton as an inclined force. Others will be a straight forces. So in that case, let me draw how the diagram will be. So let me put a plus sign here, right? So what will happen? Your T is along x-axis. So this is my T, right? This is along x-axis T. Next, 130. So look at 130. So how it is? So which quadrant is your 130? Can you tell me which quadrant is your 130? So it is at the third quadrant. So this is at the third quadrant. This is my 130. Okay. This 130 kilonewton. Angle is vertical. So which means this is 30 degree. Right? And the other one are reactions. If you consider your reaction is here. This, which is R1 plus R2. Right? Whatever reaction we are getting. So this is not an ABAC problem to identify these reactions or not. My aim is to find out what is the tension value. Only if you know the tension value, I can able to identify what is my stress. Okay. To identify tension value, I can directly go for sigma fx is equal to 0. We put sigma fx is equal to 0, which means T is equal to 130. So when you bring it on this side, it will be sine 30, right? So 130 sine 30. So 130 to 10 power 3. So converting this kilonewton into sine 30, right? So what you'll get? So what is my value of T? 65. So 65 into 10 power 3 Newton. This is my tensile force. Other things no need to worry. So I got my tensile force, right? So tension. So now we can identify what is the stress. Stress is force by area. Area is 490, which is given. So we can identify the stress. Stress is equal to 65 into 10 power 3 divided by area. So what is my area? Area is 490 mm square. So what is the value of my stress? We are getting 132.65 Newton per mm square. Any doubt on this?
This is a problem which is having you have two different types of shoes. So one man is wearing a shoe, another one is a woman is wearing a heel shoe. So you have to identify uh, which is having more stress. So that's what the statement is. So I don't want to explain the full statement. It is clear. So the weight of a man and woman both are 80 kg. Let me consider. In that case, you have to identify what is the stress developed in the shoe and who will have more pain in their leg. First step is I'm going to use particular unit for this. So unit is very, very important. So my unit for solving this problem is Newton and mm. So I use Newton as my unit. So for any forces, I will convert it to Newton. The other one is for distances, I will use mm. So now, what are my given data? So my given data, you have only a diagram related to different types of shoes and all are in mm that is mentioned. And another one is you have a weight. So weight is given here, which is 80 kilogram. So my given data is W, which is equal to, so it is 80 into 9.81, right? So that will give you your value. So what will be the value? Can anyone?
784.
784. Do you have any?
0.8.
Do you have
0.8.
0.8
8.
Newton? Okay, good. Thank you. So we identified what is our W. So that is my force. So we know the force. Only thing is I have to identify what is the area. So our aim is to identify only stress value. So only the stress developed is important. So in that case, so we can know force by cross-sectional area will be my stress. We can directly identify. So we will solve one by one. First thing is, let me go for, so let me install flat shoe. So flat shoe is man's shoe. Okay. So in that case, so this is my cross section. My cross section is having something like this. So it is having 12.5 as the width here. And this is radius. So radius is 30. So what will be the total distance? So it's like a diameter, right? So half radius plus one more. So which is 60. So this will be 60. And of course, this is the radius, which is 30. So R is 30 here. So now I will consider this as two part. So section 1 and section 2. I want to identify what is the area for this section separately, and I'm going to add it. That will be my total area. In that case, let me identify area for section 1 will be, so it's a rectangle. It's a rectangle, so which is 12.5 into
60.
So total, it will be 750 mm square. Next, similarly, I am going to identify what is the area for section 2. So it is a semicircle. If it is a semicircle, you know that it is pi r square by 2. So pi r square is for area for the entire circle. So since it's a semicircle, you'll get pi by 2 into r square. R is 30 square. Right, 30 square. So can you tell me what is the answer? Right, so 450 pi mm square. Right, so total area. So total area is, so addition of this two, right, which is 750 plus 450 into 3.14. Right, so pi. So what will be the total area? 2163. Okay, let me 0 mm square. So now we identified what is the total area here. So only thing is I have to identify stress. Stress is force by area. So which I will get forces, 784.8 divided by area, which is 2163. So what will be my stress value? 0.36 Newton per mm square. This is my answer for my first flat shoe. Let me go for the next one, which is heel shoe. So the procedure is same. There is no much difference, right? So again, the cross section is same. You have a similar type of cross section, but the value for this cross section is somewhat different. So this is 2.5. This is 7.5 into 2. So which will be 15. So there's no much difference here. Again, we are going to use the same procedure. I'm going to consider this one as section 1 and this one as section 2. So area of section 1. So this is equal to 2.5 into 15. Right? That gives you what is the total area. Yeah, can you tell me what is the area for this? 37.5 mm square. So next is I want to identify what is the area for section 2. So this is again, it's a radius. So pi by 2 into 7.5 square, 43.8 mm square. So I'll identify total area. So total area will be, so 37.5 plus 43.8. So can anyone tell me the answer? 81.3 mm square. So the next step is similar to what we discussed here. So we'll go for stress. Stress is force by area. So my force is, I think it is 784.8. So 784.8 divided by cross section areas 81.3. So what is the answer? 9.65 Newton per mm. 88.31.
Area of cross section to 88.31.
88.31 is area of cross section.
Section 2, sir.
Section 2, sir.
Area of section 2.
సెక్షన్ 2 మొత్తమే 88.3 సార్
88.31.
31.
Okay. So this will also changes, right? So this is also 88.31. 125.81 mm square. So 125.81. So what is the answer here?
6.23.
23.
6.23. 6.23 Newton per mm square, right? So now we got the values here. For flat shoe, it is 0.36. For a heel shoe, it is 6.25. So what do you prefer from this? So stress is higher in heel shoe,
Heel shoe.
right? Which means there will be lots of pain when you wear a heel shoe, right? So because since the stress is higher, right? So while you wear, so there may be that stress can also affect your leg. It causes some pain. That is one thing. Another thing, there is a possibility of easy breakage for this heel shoe.